Hello, it's Mr. Kessler again, talking to you today about solving systems of linear equations. Today we're going to talk about choosing the best method to solve linear equations. That's our objective. So to solve a system of equations, you got three different methods. You've got graphing, substitution, and elimination. Deciding which method to use depends on the exactness needed and the form of the equation. So if you're going to graph, you're just basically looking for a quick estimate of the solution, find the point of intersection. Substitution depends on the form the equations are in. So in this first case, substitution is the way to go because you've already got one variable that's isolated, the x, so you can put a box around what x is equivalent to and substitute it in for x in the other equation. Now, to use elimination, when the coefficients of a variable are the same or opposite. So looking at this system of equations, you notice 5y almost looks like a zero pair. All we have to do to make a zero pair is multiply one of the equations by -1, which would create a zero pair with the y. Okay, so now take a look at two examples here. Which method would you use to solve the following system? Well, in the first case, you've got both of the equations in standard form. It would be very simple to multiply either the first one or the second one by something to create a zero pair, so I would use elimination. So maybe you would multiply the first one by -2, which would leave you with -2x plus 10y equals -72. And now you can see how nicely you got a zero pair and you can eliminate the x values and go on to solve for y. In the other case, I think this one lends itself to use substitution. Here's why. You got one variable, the x, that has a coefficient of 1. In one step, I can move the -13 to the other side. And now I've got a new equation where x is isolated. There's the bell for the next class to come in. So -13, or 13 minus 2y, substitute that in for x. And now you can solve for y to figure out what y needs to be to make that true. So finally, let's talk about special solutions. Identify whether the system of equation has no solution, one solution, or infinitely many solutions. So in this first case, you could just substitute right in for x. You get 2 times the quantity 3y plus 12, because that's what x is equivalent to. 6y plus 24 minus 6y equals 24. Notice this. You got a zero pair right there, which cancels those guys out and leaves you with 24 equals 24. If you get an identity like 24 equals 24 or x equals x, you're talking about an infinite number of solutions. So there are infinite solutions for that. Next one. Looks like they're in standard form already, yes? So that means I could multiply the first equation by -2. Yes? If I multiply by -2, I created a zero pair, which eliminates the x's and leaves me with -5y equals 25. Yes, did I do that right? I think I did. So divide by -5. So in this case, we went on, we got one solution for y, so that means we're going to find the x value that's going to make it work, and that will work in both. So we definitely have one solution for the middle one. And finally, the last one. Let's substitute in what y is equivalent to in for the other equation. So we've got 4x plus 2 times -5 minus 2x equals 10. 4x minus 10 minus 4x equals 10. Now take a look, we got zero pairs, which eliminates that x variable. Now we've got -10 equals 10. And you say to yourself, no, it doesn't. If you end up with, if you simplify something that's not true, then that means there is no solution that will work in that system of equations. Now on to the next board. Oh, look at that. It's an elephant throwing darts at a dartboard. And finally, go to the 6.4 quick check on Google Classroom. Complete it by getting a perfect score. Take it as many times as necessary. Good luck.